Okay, the figures below are squares, and we want to find an expression for the area of each shaded region. Write your answers in standard form. So what we're going to do is we're going to write out the expression combine any like terms. And this is what it looks like. We have the big box, the yellow box, and that is measures x plus 4 on a side. So a square, as the name implies, um, you take the length of the side and you square it, right? Exactly for that reason. Okay, but what we need to do is we need to take away the amount that's not shaded, and that is a square that is x minus 1. So we need to take an x minus 1 squared away from it. So we need to expand this and then see what we get as a result. Now, I'm going to do my standard, we're going to square this binomial bit, okay? We're going to do this first one. X plus 4, we're going to square it. So x is the first term, we square it. Okay? For the middle term, we multiply the terms together, x times 4, 4x, and we double it to 8x. And that's the middle term, 8x. And then for the end of it, we do 4 times 4, 16, and we have plus 16. So that is what this binomial is when you square it. Okay? Now what we're going to do is we're going to take away, and I'm going to put this in parentheses because whatever we take away, we need to change the sign of everything so that since we're subtracting it. So we're going to say minus all of this. Again, we're going to do the same thing. We're going to take the leading term, x, and we're going to square it, x squared. Now we're going to multiply the two terms together. X times negative 1 is negative x, or negative 1x. And if we double it, we get negative 2x. And then we square negative 1. Negative 1 times negative 1 is positive 1. Okay? Now, in order to subtract this away, what we really want to do is we want to change the sign of everything inside the parentheses and then add it all together. So I'm going to keep this x squared plus 8x plus 16. And we're going to say minus, and here what we're doing is we are distributing this negative to this, change the sign, this, change that sign, this, change that sign. Okay? So x squared becomes negative x squared. Negative 2x becomes positive 2x. And plus 1 at the end becomes minus 1. Now we can combine like terms. What are the like terms? Well, we've got x squared terms, and we've got x terms, and we've got constant terms. Okay? So we're going to do the x squared terms, the green. X squared minus x squared cancels out. Just goes away. In purple, you see 8x, underlined in purple I mean. You see 8x and then you see another 2x. That's a total of 10x. And then you have underlined in light blue, the positive 16 and the minus 1 is plus 15. And that becomes an expression for the area of the shaded figure in green when you don't count the white area that's not shaded. Okay, that's the answer. We have one. Okay, we're going to sketch this because it'll be helpful if we sketch it. A square green rug has a blue square at the center. Let me sketch it first. A green square rug. So let me make a green square. I have a tool for this. Okay, there we are. And it says the side length of the blue square is x inches. So let's label that as x inches. And let me see. So this is x, that measures x, and of course it's a square. So the other sides measure x as well. The width of the green band that surrounds the blue square is 6 inches. So we're going to say this is got to be 6 inches. Okay? So then the entire length along the edge, this entire length here, would be sketched out, would be 6 inches here, then this is a length of x, and then this is 6 inches here. Okay, so what is that total length of that rectangle? Well, if you get 6 inches on this side and then 6 inches on that side, that's 12 inches total. And then we've got this plus x, we don't know what that value is. So we're going to call this x plus 12. That is the length of that side. Okay? What's the area of the green band? Well, the area of the green band is going to be whatever we get for the area of that square, and essentially it's going to be for the green square. If it was green all the way through without the blue, we would just say it's got a side length of x plus 12, and we do length times width, and they're the same. So that's would get us the area of that. But what we need to subtract away is the area of the blue. And what's the area of the blue? Well, it is the length times width, or the side length squared. And since the side length is x, it's x squared. So we're going to have to subtract away x squared, the area of the blue, in order to find out what's the green. So we're going to do our trick. When we square a binomial like this, what's our trick? Our trick is this. We square the first term, x squared. We multiply the two terms together, x times 12, 12x, and double it for the middle term, plus 24x. And then we square the final term. This is 12, so 12 squared is 144, plus 144. And then, of course, you can see that we still have, so that's what x plus 12 squared is, but we still have this minus x squared at the end from the original thing up top. Okay? This is what our squared binomial turns into. Okay? Now, you can see that we have an x squared here at the front, and that's what we're taking away, the x squared. We're taking away x squared. So if we combine this term with this term, those go away, and we get, as an answer, 24x plus 144, and that is inches squared. Yep. So if we were able to plop in some number x that we knew was the length of that blue side of the blue square, then we could calculate what's left for the green. Let's just box that answer.